Okay, I'm going to begin talking about thermodynamics today. First thing we really need to talk about thermodynamics is what temperature is. And we have different scales of temperature, as we are all aware. We in the United States still exist primarily talking about things like it's 70 degrees outside, but if it was 70 degrees Celsius outside, we would all cook. So there are different, there's a Fahrenheit scale, there's a Celsius scale, and in addition to those, there are also absolute scales that are related to them. And the absolute scale that goes with Celsius is Kelvin, and the absolute scale that goes with Fahrenheit is called the Rankine scale. Okay. Now, what do those mean? Well, first of all, I'm going to start by talking about Celsius. Celsius is part of the metric system, and they came up with that scale. They said, well, what makes sense in terms of like, why would we have a particular number be whatever? And they said, well, 100 degrees is important for water, and we're 75 or 80% water in our bodies, and we need water to live, etc. And at 100 degrees, water boils. So another number that's very important for water is 0 degrees. 0 degrees is where water freezes. And they made those numbers. They said those are important things. When water freezes and water boils, those are important things to us as humans. Therefore, we'll call one of those 0, and we'll call the other one 100. Anything above 100, water, water would already have been boiled. It would be steam. Anything below 0, it would be ice. And so that's where that scale came from. And centigrade, centa, is another name for this. And centa, that has to do with cents. 100 cents in a dollar, right? 100 degrees in this scale between 0 and 100. Okay. And, but that's not as cold as it could possibly get. There's the other scale, which is Kelvin. It says, but things could get colder. And it turns out that if you get as cold as you can possibly get in the Celsius scale, then you're somewhere in the neighborhood of negative 273 degrees Celsius. And that's what we call absolute 0. And since that's absolute 0, another scale that is used is the Kelvin scale. And the Kelvin scale, we say, well, we're going to call this one 0. But the step sizes are going to be exactly the same as they are in Celsius. And there's actually like 273.16 or something like that, but I'm not going to worry about that. Okay. So if we call this 0 degrees, then water freezes at 273 Kelvin and boils at 373 Kelvin. So that's the way Kelvin and centigrade works. Now, we also have Fahrenheit. And that's the way we have lived our lives knowing about Fahrenheit. And we know that, again, those important things like water freezing and water boiling shouldn't have erased. Well, those happen at different temperatures when we're talking about Fahrenheit. 32 degrees, randomly, no reason. This is just the scale that was chosen by whoever invented this. Okay? And 212 degrees is where water boils. And in this case, if we go all the way down to absolute 0, it's minus 459 degrees Fahrenheit. And again, there's some change there. It's like 459.46, something like that. So that's the Fahrenheit scale. And if we go into the Rankine scale, then the absolute 0. Rankine, that's 0R. This would then be 491 Rankine. And this, throw another 180 on top of that. And then at 671 Rankine would be where water boils. You've probably never heard of this. You've probably heard of the other three. Probably never heard of Rankine before. But it's just perfectly analogous to what we do with Celsius and Kelvin in that scale, the Fahrenheit and the Rankine relationship. Now, what's important to us, because we have grown up dealing with Fahrenheit all the time, when we take temperatures in the lab or those kinds of things, we tend to measure things in Celsius, and so it's important to be able to do these conversions. Well, if we start with the temperature that is given to us, and I'll say a temperature that's given to us in Celsius, okay? For instance, if I said something's 38 degrees Celsius, how do you go about converting that into into the right scale for Fahrenheit. Okay, well, a couple things. Remember that for Celsius, we start at 0. And so if we said, well, something's 0 degrees Celsius, we say, well, we know that's 32 in Fahrenheit. And so one of the things that we would need to do is we need to add a value to that in order to convert, right? So there needs to be some, we take whatever temperature that we have, and I said this backwards because I said if we're given it in Celsius. So what I'm trying to say is I want to convert from Celsius into Fahrenheit. So if I'm given some value in Celsius, okay, what would I need to do with that? Well, if I just said, what about if I had 0 degrees Celsius? Well, 0 degrees Celsius should be 32 Fahrenheit, right? And so we need to figure out how to make that conversion work. Now, a couple things to think about. This is actually an equation that works with slope and all kinds of things like that, and I always make you guys do equations. If we think about this, Fahrenheit, the number of steps between 32 and 212, that's 180 degrees, right? And from 0 to 100, that's 100 degrees. And so the slope that it actually turns out, 180 over 100, or 100 over 180, depending on which conversion we are doing, that ratio, 18 over 10 or 9 over 5, so it depends on which way we're converting, which one of those two that we use. And so that's going to be a factor that's going to go out here. Now, Fahrenheit, 212 is higher than 100 by a good bit, right? So we're going to need to multiply. When we have a Celsius temperature, we're going to need to multiply by the 9/5 here, somewhere along the way. And when we have a Celsius temperature that we want to convert to, Fahrenheit's going to be a bigger value. We're going to need to multiply by 5/9 in order to convert it. But that's not the complete conversion of what needs to happen. Okay. What else needs to happen, and again, think in terms of like, if I gave you a Fahrenheit temperature and I gave you 32, that should convert to 0. That means that needs to work. Plug in 32, 32 minus 32 is 0, 5/9 of 0 is 0, okay? And that's the conversion formula here. Now, we can also say, well, what about 212 is the other number we know about. If we put 212 in here, 212 minus 32 is 180. This ratio, which came from 100 over 180, is going to become 100 when I multiply by 180 here. 180 over 9 is 20, 20 times 5 is 100. So that formula works there. Now, for the other conversion that we do, of course, you can take this formula and rearrange it. We distribute various things, etc. And so we could solve for T sub f from this formula. And if you think about doing that, what would we do? We'd multiply each side by 9/5, and I'd have this. And then I'd add 32 to each side to get T sub f by itself. So in this case, I have to add something, but I don't just add 32 inside parentheses. I just need to do this right here. That's how I convert that. So now again, I think about that and I say, well, at 0, this would be 0, and temperature Fahrenheit would be 32. At 100, this would be 100. I give you 180 plus 32. So those are the two conversions that we need to go back and forth one way or another. If you're given Celsius, you use the top formula. If you're given Fahrenheit, you use the bottom formula. If you remember one or the other formula, you can fairly easily do the algebra to get to the one that you didn't remember.